Okay, welcome back to my shop. Today we have another Symetrix 528E that guy sent me from Georgia, I believe, or no, South Carolina. And he says that it does not work and that it makes a terrible hum, and the outputs are, the 48 volts doesn't work when he's trying to use it for phantom power. As usual, these things are full of capacitors, all of which are bad, I'm sure. Anyway, let's find out what he says here. Plug it in, and okay, well, the first thing you notice is that there's the output, and that's not good. No, it's pegged. Over here's the de-esser, and it's yeah, nothing. Well, let's see what it sounds like. Take a listen to it here. Ground is ground. Let's see. Here's your output. That's both sides of the balanced output. Alright, well, I can pretty much guarantee you that the caps are bad. And this time I mean these guys here. The big ones. I'm sure that all the little guys are bad too. But the big ones are not good. Oh, wow. No. Actually, that's interesting. The compressor, well, part of it's working. Okay. Well, we'll replace the big caps first. So, I'm sure that is needed. So, let everybody heat up here, and we'll do that first, and we'll find out. What we're going to find out is, first of all, if it's just the caps, which it certainly sounds like, but none of them are showing any signs of leakage at all, which is kind of unusual. But sometimes these amps in here can be bad. We had it on for a few minutes, and no, nothing's warm. So we'll see. Take her apart. Alright, these guys don't have a heck of a lot of screws holding them together. Probably more than it's needed. But remember, this is a professional piece of equipment. For the price it better be. These things like retail for over $1,000. Got to take the little few screws in the back out here. Looks like about it. Oh yeah. And take the grounding lug off. Which is right. Ooh. There, and it's Loctited in. I don't know why. Alright. Alright, so that's off. Now, we pull off 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 knobs. Never ceases to amaze me how many knobs are on these things. All right, and then you got to take, well, yeah, you got to take that front off, because if you don't take the front off, you can't. It's attached to the back here also. And this is held on with littler than that. I believe these are 16th. Yep, 16th hex heads. The only Symetrix likes to do this with these hex heads. I guess they think they look better than regular screws sticking out the front. Really can't argue with them. Fortunately, it's not some weird metric size that can't get. I'm sure it is metric, but 16th works just fine. I believe I lost my metric Allen wrench that would fit these. All right, there's that, that, and oh, I forgot. More screws on the bottom, holding the whole mess in from this direction. They wanted to make sure this thing did not fall apart. And out she comes. There's the whole board. Got this little guy, which just has the drivers on it for the LEDs, all of these, and for these. And it's ribboned in there and doesn't come off. They didn't bother to put connectors on it. Anyway, so we're going to check. We're going to start with these and find out, first off, if the what they look like as far as ESR or even value or whatever. So let's get rid of this for now. Here, you can live up there. So, interesting, just for sake of, I wonder if that could be part of it. It's got some bad spots on here. If you look, yeah, that's goop. It doesn't appear to be actually bothering anything, but we'll find out on that. That's just something I noticed. Is it? Yeah, that's all over the place on here. Just a little bit of it. We'll find out. All right. Well, first off, we do the big caps. They are right here. I'm willing to bet that one or both of these are bad. Gotta remember, these things are basically new in 1997, so they're definitely time for the capacitors to be replaced. What the? Okay. Sometimes you have to coerce them just a little bit. Remember which way both of these come out. Negative this direction. And they're not showing any signs on the bottom. 1000 microfarad to 50 volts. Well, magic box time. Ooh. Tell you, the old days before we had these, I'll tell you, these things are great. I have an old pyramid capacitor tester, tube type capacitor tester under the desk, and it's okay. There is what it's showing for the capacitor. That's 180 microfarads. 180 microfarads at 7.8% V-loss, 3.9 ohm ESR. That's supposed to be 1,000 mics. Okay, did it twice, came up the same thing. Try this one and see what it says. 30 puff. Yeah. I think at 33 picofarad. So that one is open. Yeah. Okay. Those are bad for sure. So I did order parts for this because I was pretty darn sure I knew what I was doing here. And there's several. There's 4 of these in here. It'll be interesting to see what the other ones are. But they're all power supply filter caps. So I would be willing to bet a large cherry pie, which is my favorite, that those 2 are bad. But for sake of testing in the videos, we're going to try it just replacing these 2 so that you can see what a bad filter cap could do to you. They're normally they give you a pretty clear indication that they're bad, but like this does. Sometimes not so much. All right, turn on the little squawker. Yeah. Make sure there's nothing under here because that's 110 volts AC right there. No touchy. Okay. And aha, LEDs are not on anymore. No buzz. All right, so that took care of the big buzz problem. But I can guarantee you that the rest of them are bad. Let's find out. This might well be a pretty long video. Okay. Take out these 2 on this end. They are another set of 1000 mics at 50 volts. If you're going to do this, just go ahead and do it all don't say that one's good. Why bother? Because they will go bad eventually on you. Test this one. It's got that white stuff on the bottom of it. I don't know what that is. Takes a minute for these big capacitors. 888 at 0.44. So that one actually probably is okay, but I'm not going to do that because I just don't believe in it. They're not that expensive, and it's just best to replace them so that when you say you've recapped something, it's actually completely recapped. This is a double-sided board, and they got pretty good ground traces on them. On this side especially, it's pretty heavy duty. Okay, let's test this one. I'm only testing these because for the video I would just replace them and not even think about it, but it's nice to see. Whoops. No, a damaged part. Yeah, I'll bet. Okay, lead fell off. Got to get better leads. And this one is 900.4. Yep, that one is definitely good, but we're going to replace it. For the cost of them, it's just not worth it. Okay. Following the little signs that tell you what side goes where. By the way, when you go out and buy capacitors, or any other part for that matter, but especially for big capacitors like this, they all come in various sizes, and they have different gaps here between the leads. So make sure when you order them that you get the right ones. Some of them are much taller, some of them are much shorter, and you really need to make sure that you get the right ones, because you're going to play heck with it if you don't get the right ones to it. Yeah. Unfortunately, on some of these, it's like they designed these never to be fixed. They print the pads on the bottom of the board, but they're just pads. They're not actually attached to anything on the board. So when you're putting them back on, because your pads will pull off with a solder sucker, pretty much guaranteed no matter what you do. And you just got to make sure you got enough heat to get through the metal to get to the top, because as you can see here, you're not getting underneath that thing to do it, but it is down there good and tight, so that's fine. So there's our 2000s, 1000s. Let's go over here to these other guys. I'm trying very, very hard not to pull the pads off the bottom of this one. It is so difficult because really there is nothing, literally nothing, holding that thing on there. Except for the fact that it was copper on a printed circuit board. As you can see, here I'll show you. As you can see on this one, the pads on top, right there, the actual traces and lines. On the bottom, all you got is that. Absolutely attached to nothing. It's just, if you accidentally pull the pad off, don't fret. You haven't ruined it. You just gotta make sure you have enough heat to get through, or back through the hole, because they're plated through, the holes are, but you got to make sure you get enough heat on there to go through the plating and get the top side connected. Happens all the time. Doesn't mean you're a horrible solderer. Alright, let's see what this one is. Taking a long time. 38 microfarads, 9.2 ohms, 8% loss. Alright, it's supposed to be 47 at 100 volts, but 9.2 is way too high. The way this goes, the higher the value of capacitor, for the most part, the higher, or the lower the ESR, equivalent series resistance, is going to be. When you start getting down into the little 1 microfarad guys, getting an ESR of 3 or 4 or something like that is not horrible. But 9 for a 100 microfarad, no, that ain't going to cut it. Alright, so, by the way, I could not actually get some of these exactly the same size. However, I do have, these are 47 at 100. I do have, those are 47, 100, caps, 47 and 100. Okay, I have a lot of room to work with in here, so it's not a big deal. There's going to be several of those. Yeah, so if you can see here, let's do it this way. See the caps I got. This is the one I got, and this is what came out of it. And here's what I'm talking about. There's a difference in height. However, if you turn them over, the lead spacing is the same. So I'm good on that. And I got plenty of room in here to play with. So that's, wow, how did I do that? That capacitor is not sitting flat on the board. Okay. Alright, there you go. I'm going to check this just in case, because it's always a good idea if you get something that you don't know. Bought it brand new, and who knows, it could be bad. So this one's going to come up as, yeah, there we go, 46.2 microfarads, 0.5% loss, and 0.57 ESR. That's accurate. That's correct. So that's what you're looking for. And along the lines of capacitors, when you're buying them, don't cheap out. If you go into someplace like DigiKey or Mauser, the very first line usually is the cheapies. Go down a few lines, get the better ones. You'll never be sorry. I flat guarantee it. Alright, so there's that one. And this one. This one, I believe, is another 100. 47 at 100, yep. Okay. Like I said, we're just going through this testing process of these things to see which one of these are actually bad. And probably most of them are going to be a little low or bad in value and just a little high in ESR, but not so that they're just terrible. Like this one's 45, 8.3% loss and 2.1 ohms. It ain't going to get any better sitting in here working, so, you know. All right. Let's check another one. By the way, on these little testers, if you get yourself one, you have to do the test between pins or inputs 1 and 3, or it won't show you the ESR. It's in the manual, way down at the bottom in fine print that you need a microscope to read. Okay, 45 microfarads, 0.58 ohms. That one's good too. Being careful to make sure that you put it in the right direction. Yes, I have put them in backwards. Yes, it's generally reasonably catastrophic when you do that. Alright, and when you're cutting off leads on capacitors or resistors or whatever you put in, you want to make sure, just as a little side lesson, you want to make sure that you don't cut into the solder itself. Just like that. Make sure the solder is good, and make sure that you're not actually, whoa, I hit a button. Well, that's interesting. I didn't know I'd do that. Huh. Okay. I thought it'd take a picture. No, it changes pictures. Okay. Make sure that it's nice and clean and that it's not cold solder joint. This particular type of board that's on these things, there we go, is it's this type of board. I don't know what it is. Dave Jones could tell you, I'm sure, but it's the traces are just, you can tell it was routed by machine. It's no curves, just angles, but it's the traces and the pads are very, very small for most of the parts. As a result, you end up with not perfect looking solder joints. All right. One thing you want to be careful of is when you do this, make sure that you don't pull, make sure you get it unsoldered out of the way so you don't like pull the traces, the feed-throughs right out with it. I mean, if you have to pull hard, you've done it wrong. Go back. This one is slow, means it's working. 45 ohms, 1.4 ohms, still 7.8% loss. Okay, so all of these 47 and 100 were, in my book, anybody's book, not good. So we'll make sure that it's a good idea that we replaced them. Would they have worked? Yes, they would have worked. You saw that. They would have worked. However, they're not the right way to do it. Get the fingers off there. 0.59, 46 microfarads, 0.59 ohms. That's good. All right. Plus over there. I wonder if Dave Jones ever watches my videos. Probably not. I tell you, I got a lot of respect for that guy. He's so much smarter than I am. He's cool. All right, so that's got these. Oh, here's one more. Yeah. This, I believe, is the 100 microfarad one. You do have to wiggle a little bit when you take them out because the leads are bent over, so it stays on the motherboard or the board when they swipe it. But yeah, you got to look at the bottom and make sure the leads are moving, and don't pull on it with a pair of pliers hard, because you're just going to rip the pads off. Okay, and this one is, yeah, okay, this guy is 81.5 microfarads, 5.1% loss, but it's still 0.58 ohms, but it is a 100 microfarad cap, so it still has the 5% loss. It's good on ESR, but it's changed in value, and it's on its way out. So we're not going to leave that one in there either. We're not going to leave any of them in there, to be honest with you. When I get done something like this, I want it to be as close to perfect as possible, because my name is on it. If my name is on it, I want it to work. Why am I having such a hard time getting capacitors to actually sit where they're supposed to sit today? I'm not down on the board that time. Okay. Alright. So, there's all those guys. Now, oh no, there's one over here. This one never goes out. It's part of the .48-volt phantom circuit, and this one is always fun because it actually literally doesn't have any pads on this side. Alright, this one is another 47 at 100. What's your guess? 47 at 100 on a 48-volt line. Oh, well. But it's awfully, awfully low current. None. This is probably fine. We'll find out. 0.51, 1.6, 45. Yeah. It's okay, but we're not going to leave it. And don't stick these in your goodie box either. You'd be tempted to say, "Oh, that one's good. Let's keep that one. Put it in the bins box for experimentation and fun." Yeah, don't do that, because you get a hold of one that you've put in there last year, and you completely forgot that what you took it out of. The thing you're experimenting with is not working because it's got a bad cap in it. Okay. All right. Now, let's check. The other thing we got is these little guys right here. These are non-polarized capacitors. They're used to couple stages. Can I get a picture of it here? See the NP? That means it's two capacitors back to back and not polarized, so it's not going to do what a cap does. Trying to get the other side. And they're 47 microfarads at 25 volts. Oh, I love the way they did that. Okay. There we go. 47 microfarads, 25 volts. they do go bad also. And there's 1, 2, 3, 4. There's 4 of them in each one of these units. So let's try one. What they do is they couple the different stages between the different functions, like you know, the de-esser, the expander and compressor, and all that stuff. And they go bad. ESR goes high. They start passing voltage, and everything looks like it's working, but it will not sound good. It will sound absolutely horrible. And you can check these just like a regular cap. As far as this thing's concerned, it is just a regular cap. Yeah, okay, there you go. Let's take a picture of that. We have, I want to show you what a truly bad capacitor looks like. This one is truly bad, and you'll find a lot of these in these machines. That is what a completely bad capacitor looks like. And that is one of the feed-throughs, 0.14K. That is 140 ohms. That's as far as this thing will go. That means it's shot. Okay. All right. Now, here is an NP, or sometimes they're marked BP, bipolar, but it's a non-polarized capacitor that's not marked on the board, so you don't have to worry about which way you put it in. These boards you cannot possibly get the capacitors that went in them. They're just not, they're not available, so you get anything that'll go. These are a little bit too narrow as far as the lead spacing goes, but they work just fine. Alright, so that tells me all the rest of them are bad. And besides, I was going to replace them anyway. I'm not even going to test it. I know they're bad. They just age. Just age. It sure isn't voltage. These things only got about 5 volts on them. DC wise, little AC voltage may be getting up to about 8 or 9 volts, but what happens to capacitors is they dry out. The insides dry out, usually from heat, and when they do that, they just change values on you, or they become a quasi-resistor. There we go. All right. Put 2 of these in here. I did accidentally one time put a polarized resistor in here. Strangely enough, it didn't make much difference. But that's not what the engineers came up with, so I'm not going to doubt them. They generally know better than me. Sometimes I wonder. But on something like this, on professional equipment, you can pretty much guarantee that they knew what they were talking about. Don't try to re-engineer for them. Alright, so that's all those. Now, those guys are done. I put all these away. That's replacing the through-hole capacitors on a 528E. Noise machine on, and needlepoint soldering iron. I've already done this next part online. If you want to see it, the original 528E repair. So I'm not going to make you sit through all of this. Basically it involves replacing all these little tiny guys right here, and it's fiddly. They're surface mounts, and it just takes. You got to heat them up enough to pull them off, clean them off, put them back down, and solder, heat them back up. These guys are big enough. I don't have to worry about. Actually, I don't heat them back down. I use a soldering iron, the little needlepoint guy, to solder them back on. But I won't put you through that. We'll come back when this is done, and then we'll run it through its paces. Probably we're going to have to replace one more of these switches here too, because they're, I don't know, just junk. Yeah, especially that one. I can feel it. Okay, we'll be back. All right, we're back. We've got all of the capacitors in, as you can see by the picture. They all went in pretty well. Didn't destroy anything in the process. And we have a very nice tone in the background. Well, that tone is what we're testing now to see what else is wrong with this thing. First of all, we're going to find out if all of the functions on it work or not. And to do that, we have a generator, this guy here, little audio generator. It's actually a sweep generator, but it works fine, and we're going to sweep it anyway. And we're going to put it through its paces a little bit. And the first thing we want to test is the compounding, or compressor ratio and expansion ratio, to find out if it's working. And in that, it's pretty easy. All you got to do is look at the knobs here, or look at the buttons, the lights on the board. And basically what you do is you feed it a signal. I've got a signal up here in the scope, and you turn the button on and see if any lights come on. They did. And you take the compression ratio up, companding, and what you do is you watch the two different sides. You can see them here. This over here is the output. Let's see. Yeah. Hello. Yeah. Where am I? Hello. Okay. This over here is the output, and this over here is the input for the compression ratio. And basically, as you bring the compression ratio up, the output should go down. What that does is, the louder you go, the less output it has. And so you set it at one light on, and then we turn up the input to it, and as we turn up the input, the compression should go up a little bit. Let's do it a little more so you can see what happens here. There you go. See? Now we got almost no output at all. The output goes up, but as the output goes up, the little red light here will never come on, because it's compressing downward, so that you never get too loud above 0, which is that last yellow light that you see there. Alright, So that part is working just fine. Now we want to do the threshold of it, which means we give it a signal and we adjust the threshold so that take the signal down to nothing to start with, turn the compression up, and the threshold is that second set of lights over there. There. With no signal whatsoever, or just noise. And then you give it some signal, even a little bit. Those will go out. So now, when there is no noise at all in the room, I can't turn this function generator to off. When there's no noise at all, it'll shut off. And we know that that's working because we turned it off when it was completely nothing there. Alright, now we want to check for the expanding. Expansion will expand out when there's no audio or less audio in it. So we set the expansion threshold so that it comes on with just barely comes on with nothing, and then we give it audio, and it should go out because it's got plenty and it doesn't need any, and you have audio output on this end down here. Okay? Alright, so we've proven that the compression is working and the expansion. Now we want to turn that off, and we want to do the de-esser. That takes some of the sibilance out of your voice. The de-esser is over here on these guys. Basically, at 1 kilohertz, which is what I'm feeding into it now, you turn your de-esser up. So you've got your de-esser 50 kc set, which is really high. And as you go up in your frequency, if I take this up to 10 kilohertz, the de-esser cuts in on full. So we want the de-esser to be in on full on 10 kilohertz, and on 100 kilohertz we want it to be, or on 1 kilohertz we want it to be down about there. Let's take it back to 10. Up it goes. What that does is that takes the sibilance out of your voice, and you know, the little, it de-esses it so that you don't get that psst, 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 psst. And it also, at the same time, when it's in there, if you'll see, over on this side, it cuts your audio. This cuts your audio down. There, the audio goes out. Now with 10 kilohertz, it's down. So the de-esser is working. Let's cut off the de-esser and put in the frequency, the equalizer, and we will take our output down to about 600 hertz. Let's see, 1K, 600, sine wave. All right, give ourselves some output, which we have over here, and we'll adjust the 600 hertz and see if we can cut it off. And we are. We're cutting off 600 hertz approximately, and way too high. So basically, yes, that's working. Then we go to mid frequencies, about a K, or at least close, kilohertz, and we try the same thing. There we go, with 1K, and you can see that we can set the threshold, which is this one, and the how well it works, and the actual output of it we can take down. So that part's working. And then the high, we'll go to like 6 kilohertz and do the same thing. There is a 6 kilohertz. We tuned it in, and now we should be able to, tune it down. So get rid of the 6 kilohertz or boost the 6 kilohertz, either way you want to do it. If you can hear that, pretty high frequency. See, I can cut it or I can boost it. Right in the center, there's a little detent on this knob, and that's 0. And so it doesn't do anything because you're not doing anything to it. All right, so we've proven that that works. The equalizer works. Let's take this down to 1 kilohertz. That's an annoying tone. All right, now we want the voice symmetry. You really can't test voice symmetry until you actually get it in. All you can do is listen to it and see if it changes. What that does is it's more of a gain. The symmetry is more of a gain reduction for input of speech. If you look at it, like I said, it's more acoustic than anything else, and auto acoustic, and you really can't tell. But it is working. I can tell from experience when you push the button what it does. Okay, now we get to sweep it. So we got to find out, make sure everybody is off, and this is pretty amazing, but all the switches were good too. That never happens. All right, so now we're gonna take a picture of the scope, and we're going to sweep it. Sweeping means we're going to go from a low frequency to a high frequency, or reverse, but in my case from a low frequency to a high frequency, and see what its response is on an oscilloscope. Ideally, it should be exactly the same height. The trace on the oscilloscope should be the same height all the way from the low frequency up to the high frequency, unless one of your EQs is cut in or your de-esser is cut in or something like that. We're not going to do that because we've proven the de-esser works at the correct frequencies up above about 6 kilohertz. All right, so there on the scope, let's see, and record. Okay, there on the scope you can see we've got that wave pattern, which happens to be approximately 2, 4, 6, 8, 10.2 volts. I think, my time, no, 10.2 volts, peak on the scope. We're going to turn on the sweep generator. First I'm going to put it on 10K. There it is. There's on 10K. And I'm going to turn on the sweep generator. And you can hear it. And you can see from 0 to 10K, that thing's just flat as a barn door. Turn this down. Now, just for fun, what happens if we cut in the de-esser? Watch this. Whoa, the higher it goes, down in frequency it goes, and I can adjust that some so that the de-esser doesn't do very much, but it's always going to do something at the top where the sibilance is. The sibilance. Okay, so let's take the de-esser out. Let's put in the frequency, these things, equalizer, and we'll see what we do with our equalizer here. Let's turn our equalizer on for low frequencies. And see if we can, there's a little dip right there, so you can see it. That's boosting the low frequency, see, way higher and then down to the point where it's actually flat topping. Put it in the center. Now let's try it with the mid frequencies. Turn it down here and turn it right about there. There's the dip in the mid frequencies and boost in the mid frequencies, and it sort of carries over into the rest of the stuff. So that's going to get everybody. Put that back in the center, and let's try the high frequencies. Let's cut them down. High frequencies go way down. Mains high, low, and with boost in the high frequencies, there it is. Oh yeah, that's ugly. All right, so that's how you sweep an audio output of well, any kind of a thing. Now this is going with line in and line out. So what we need to do is check the microphone output, which is 50 dB down, which is a lot. That's like almost nothing. Whoops. Okay. Okay, so we'll check our line out. There's line out, as you can see. All right, let's stop the sweep. Put it back on 1K. There. All right, so there's line out, which is on this one, I believe, 0 level, 0 dB. And there's 50 dB down, which is Zippo. Yep, we are now at 50 millivolts per division. So we got 50, 100, 150, 155, 153, somewhere around there. So we went down exactly as much as it's supposed to. Back out, wham, here it is. So that's working, and the switch is good. That's amazing, because usually these switches all go bad. So we've proven that all that's working except for the mic input. And now we'll do that. Mic input, I don't really have anything that'll go down that low. That's what it looks like when you put too much in the mic input. That's down as low as it'll go, and I can't get it any lower. This little guy won't go down to 0, unfortunately. But I know that the mic is working because it's down to nothing as far as I can tell. Okay, so there we go. Plugged it back into the back into the line input, and as you can tell, I don't hear anything. Yeah, because the line input's got to have a lot more gain, and you can see nothing on our meters here. Okay, so that's all working. So we have proven beyond a shadow of a doubt that this thing is working as good as it can. That's perfect. De-esser works, everything works. Now, his other complaint, I believe, was that the 48 volts wasn't working on the mic input. I believe that was probably because of this bad cap over here that we replaced. But we'll find out. What do we got? So negative, positive. We got no voltage on the mic now. Turn on that, and we have 46.6 volts. Yep, it's working now. So there we go. There was no real troubleshooting here. It was just a bunch of caps needed to be replaced, which, quite frankly, is a whole lot of repair. Is replacing bad stuff, and then making sure that it's right after it's done. So everything is working. The thing is in my opinion, perfect. And we'll pack it all up into this box and send it back to him. So, thanks a lot for watching, and we'll see you again. Make sure to press the like button and to go to the thing. Let's see, where is it? It's over there. Yeah. Subscribe. Go to subscribe to the channel so that you know when I put out another video. So, have a good day. Talk to you later.